let's go ahead and solve the linear system problems by using the addition method. And for these problems on section 6.2, basically you want to eliminate one of the variables, being x or y, by either subtracting or adding the equations so that you can isolate for one of the variables. So sometimes you might add, sometimes you might subtract, and what you need to really do is analyze both equations and see which method works best. So in this very first problem, I noticed that there's a negative y and a positive y. So I can eliminate the y variables by simply adding the two equations. Okay, so I'm going to add the first two equations here by having a plus sign here. And let's just see what happens when I add the two equations. So what's x plus x? So if I add x plus x vertically like this, x plus x is going to be 2x. And then if I have my negative y here, negative y, and then if I add that to a positive y, you'll notice that the y variables cancel out. So it's really a negative y plus the positive y, and that gives you a 0, right? So the y variables cancel out. Now, if I look at the constants here on the right-hand side, I have a 4 and a negative 6. I'm taking my 4 and I'm adding that to my negative 6, right? So 4 plus negative 6 is going to be negative 2. So on the right hand side, I have a negative 2 when I add the constants there. So 4 plus negative 6 is going to be negative 2. Then from here on, you want to divide both sides of the equation by 2. And you'll notice that these 2's cancel off. And negative 2 divided by positive 2 is going to be negative 1. So there is the value for x, and what you need to do now is you need to go backwards now and find the value of y. A very good strategy is for you to rewrite the first equation, which is x minus y equals to 4. And I know that my x value here has a value of negative 1. So let's go ahead and substitute that in. So negative 1 minus y equals to positive 4. And then this minus 1 can move to the other side, to the right-hand side. So I have negative y equals to 4 plus 1. And 4 plus 1 is going to be 5. And then finally, I can divide both sides of the equation by negative 1. And that means y would equal to negative 5. And although that's the correct answer there, you should definitely finish off the problem by writing your answer as a coordinate. So x is negative 1 and y is negative 5. So write your answer as a coordinate, negative 1 comma negative 5. Okay, let's move on to the second question here. And what I noticed for this particular problem is that there's a positive x here and a negative x there. So I can eliminate the x variables by adding both equations here. So I'm going to add both equations just like the previous problem here. And what's happening is you have this single x, and then you're adding it, right? You're adding it to this negative x. So x plus negative x is going to be 0, right? So the x's will cancel off. After that, I have my y variables, right? So I have a negative 2y. So I have a negative 2y, so that's going to look like this, negative 2y, and I'm going to add that to a positive y. And negative 2y plus a positive y is going to be negative y. So if I add the y variables vertically, I get a negative y here. And then finally on the right hand side, I have a negative 1 and a positive 1. So that's the same thing as negative 1 plus a positive 1, which is going to be a 0, right? So on the right hand side, I have 0. So I have negative y equals to 0, and you can divide both sides by negative 1. This will give you a positive y on the left hand side, and 0 divided by anything is going to be 0. So for this problem, I know my y value, my y variable has a value of 0. All right, so if I erase my work here now, and if I go back to the original problem, and if I highlight this first equation here, that's going to be x minus 2y equals to negative 1. You'll notice that the y variable here has a value of 0, right? So that's going to be x minus 2 times 0 equals to negative 1. And 2 times 0 is going to be 0. And that means x equals to negative 1. So the final thing to do here is write your answer as a coordinate. So x has a value of negative 1 and y has a value of 0. So your answer is negative 1 comma 0. Okay, let's move on to the next one here. Now for this problem here, you'll notice that you cannot eliminate one of the variables by adding the equation here. So what I recommend doing here is you would probably want to subtract these equations. So the good thing about the problems in section 6.2 when you're solving a linear systems by addition or by the addition method, you have two options. You can add or subtract. And for this problem, I'm going to subtract to eliminate one of the variables because x minus x is going to be 0, right? Now, before I do that, I find that in the beginning, sometimes students kind of struggle with this minus sign because that negative sign is really distributing onto everything in the bottom equation here. So this minus sign distributes to that. It distributes to this and also distributes to that. So if I had to rewrite my second equation, it's really negative x plus y equals to negative 6. And my first equation would remain the same. Okay, and then let's go ahead and see if I can limit one of the variables here. And what you're really doing is when you times the bottom equation by that negative sign, now you'll see that x, actually if I actually add these two equations now, x plus negative x, that's going to eliminate the x variables, right? And then if I have the y here, the 2y here, I have a 2y, and then if I add that to this positive y, I get 3y. So if I add that vertically now, that's going to be 3y. And over here now, that's going to be 3 plus negative 6. And 3 plus negative 6 is going to be negative 3. Okay, and then from there, I can divide both sides by 3. Divide both sides by 3. You notice that those 3's will cancel out. And negative 3 divided by 3 is going to be negative 1. So my y variable has a value of negative 1. And let's go ahead and go back to my very first equation. I have x plus 2y equals to 3. So I have x plus 2 times negative 1 equals to 3. So I'm substituting this value of negative 1 back in for my y variable. If I do that, I get x minus 2 equals to 3. And that means x would equal to 5. So my final answer here is going to be 5 comma negative 1. All right, so for that particular problem, I did subtract the second equation there, and I kind of rewrote the second equation by distributing the minus sign, and I'll do that one more time on this next problem, and hopefully we'll get a little more comfortable when we're subtracting the equations here. Okay, so for this particular problem, I noticed that I cannot eliminate the variables by adding. So what I'll do is I will subtract. Now when I'm subtracting, the bottom equation will change because this minus sign is distributing to everything in that second equation there. So if I have to rewrite my second equation, that's going to be negative 3x minus y equals to positive 11, right? And then if you want, you can just rewrite. I recommend writing the first equation just above it, and I would just add the columns vertically. All right, so add the columns vertically now. So 3x plus negative 3x, that's going to be 0, right? So the x variables cancel off. And then I have a negative 2y plus a negative y. So negative 2y minus y is going to be negative 3y. And then finally, I have a negative 5 plus 11. So negative 5 plus 11 is going to be positive 6. And then I can divide both sides by negative 3. And then y would equal to negative 2. All right, so now that I have my y variable figured out, let's go back to my very first equation, which is my first equation is going to be 3x minus 2 times the y variable, and y has a value of negative 2 equals to negative 5. All right, so I got 3x plus 4 equals to negative 5, and 3x would equal to, and if I bring this positive 4 to the other side, negative 5 minus 4 is going to be negative 9. And then I can divide both sides by 3. And then if I do that, x would equal to negative 3. All right, so my final answer here is going to be negative 3 comma negative 2 as my final answer. All right, so that's it for this first part of the homework video guide. I will go ahead and solve the next few problems in the next video.